All right, we're going to do this one in two parts because it's kind of a doozy. We've got polynomial division, and we're doing polynomial long division, but we're going to separate this in two videos. We'll do long division today, and we'll do synthetic division tomorrow. And if you'd like, I can do a video on the box method as well. Okay, you can divide polynomials with long division in a very similar fashion to how you do it with numbers. So let's take a look at example 1. Divide x squared by 5x plus 6 by x plus 2. Now, most of the time, we're not actually going to use polynomial long division on a problem like this because this is a quadratic and I could factor it. What we do polynomial division for is to check factors when we can't use these factoring methods that we've seen in the previous videos. Okay, so I'm going to set this up like I have been, or like I would for a long division problem. The dividend goes underneath. That's x squared plus 5x plus 6, and I'm dividing by x plus 2. Now normally with old school long division we would be asking ourselves, how many times does x go into x squared? But I'm going to kind of change the way I ask that a little bit. Instead I'm going to say, what do I multiply x by so that the product is x squared? I'm asking myself this question, x times what gives me that x squared in that dividend? And the answer to that is x. Whatever I find for that, I'll put exactly where I would in long division. Okay? So I'm asking myself, what is this value so that when I multiply these two things, I get x? Okay? Just kind of highlight some stuff here so you can see where stuff comes from. All right? X squared came from right here. All right? And then the value that I found, I put on top. Now, after we find it, we have to multiply just like you would with long division. So here, I'm going to multiply this x times the x, and I'm also going to multiply it by the 2. This is my whole divisor, so I'm multiplying by the divisor. This is a lot like distribution. So x times x is x squared, and x times 2 is 2x. Okay? And then we subtract, just like regular long division. X squared minus x squared is 0. And 5x minus 2x, excuse me, is 3x. Bring down the next term. From here, the whole process starts over. Once again, I'm going to ask myself, what do I multiply x by so that I get 3x? Well, I've already got the x, I just need 3. So that's what I put here. And then we multiply again. 3 times the x is 3x, 3 times the 2 is 6, and when we subtract, in this case, you'll see that 3x minus 3x cancels out, and 6 minus 6 is 0. If you recall, this thing right here is our remainder. Now there's two things that we really like about this. Thing number one is if I get a remainder, that means that this divisor goes into this dividend. Or a better way of saying that would be that x plus 2 is a factor of x squared plus 5x plus 6. That's what we really do this for. We do polynomial division to see if we get 0 for a remainder, and if we do, then we can determine that this expression here that I've got is a factor of the polynomial. There's another thing that I can do. I can take my dividend, x squared plus 5x plus 6, and write it as the product of the divisor, x plus 2 times x plus 3. And this looks a whole lot like the kind of factoring that we've done with quadratics. Okay? That's why we do it. We do it to identify factors and to break it down into their pieces. All right, like I said, we're going to do our synthetic division stuff tomorrow. I'm going to do one more long division method here. I want to take a look at what happens when the remainder isn't 0. So let's set this up. Notice this is cubic, so it's a little bit longer. So I've got 3x cubed minus 2x squared plus 3x minus 4 divided by my x minus 3. And I start the whole process over again, right? What do I multiply x by so that I get 3x cubed? Well, I need to get the 3 because this is just a coefficient of 1. So 1 times 3 is 3. And then x times x squared is x cubed. So then I'm going to multiply down. 3x squared times x is 3x cubed. And that's pretty much always going to match because I picked this number so that when I multiply it by this, I get the same. Okay. Now 3x squared times the negative 3, that's a negative 9x squared. And we have to be careful here because when we subtract, now we're dealing with subtraction of negatives. I've got a negative minus a negative. These are going to cancel out, but those double negatives are going to turn into positives because subtracting a negative is the same thing as adding a positive. Double negative, right? Negative 2x squared plus 9x squared is going to be 7x squared, and we bring down the next term. And then we repeat. This is it's an iterative algorithm, okay, meaning it repeats itself. Start over. What do I multiply x by to get 7x squared? That is 7x. 7x times x is 7x squared, and 7x times negative 3 is negative 21x. Once again, minding the double negative. When I subtract, that's 24x minus 4. And then one last rotation. You'll know when you're at the end, when you're bringing down your last term. You'll know you have to go through it one more time. So here, what do I multiply x by to get 24x? That's 24. And I multiply to get 24x. 24x. 24 times negative 3 is negative 72. One last time to mind the double negative. And that's 68. So my remainder in this case is not 0. So what does that mean? Well, a couple of things. One, it means that x minus 3 is not a factor of this polynomial, the 3x cubed, minus 2x squared, dot, dot, dot. Okay, don't mind that. Ignore that plus sign. Adding a negative is the same thing as subtraction, right? And then also, another thing that we can say here is that I can write this as 3x squared plus 7x plus 24 with a remainder. So plus our remainder over our divisor. And it looks like this. A lot like, this is a little confusing for some folks. It's a lot like if I had 12 divided by 5, right? Well, I would have 2 with a remainder of 2. So we would write it as 2 and 2/5. 2/5 left over. This is the part of the whole that's remaining. Okay? I need to make one quick note here about some problems. If you look here at this problem and compared it to these problems, you'll notice that I've got a couple of terms that are missing, or at least one term that's missing. There's no squared term here. It's important that with these problems, all of your different powers or your exponents are represented. So you're going to need to fill those in with 0 coefficients so that they're all represented. So I've got minus 6x plus 8 there divided by x minus 2. We do that to make sure that everything lines up how it's supposed to.